Okay, this is part 2 of lesson 3, and I'm starting out by showing the answers to the 6 that go with example 1 with the graphs that we did together in the last video. So here are the answers to those 6 problems. So take a look at those, and then again, if you have any questions, we'll go over them in class. Okay, moving on now. We're going to look at lesson 2, where this time, again, we don't have explicit values for the function, but we are given the values for the limit at arbitrary values of x, at c. So we know the limit of f of x as x approaches c is 3. The limit of g as x approaches c is -2. And the limit of h as x approaches c is 4. So we're going to use those values and our properties from the beginning of the last recording to find the value of the following limits. So the first one, we're finding the limit of the square root of 3 times h of x minus 2 times g of x. So we want to rewrite this using our limit properties to look like this. This is going to be, in parentheses, 3 times the limit as x approaches c of h of x minus 2 times the limit as x approaches c of g of x. And the reason why I started that bracket is because the whole thing, when we find the value, we're going to take the square root or raise it to the 1/2 power. So substituting in everything we know, this is going to be 3 times the limit of h, excuse me, which was given as 4, minus 2 times the limit of g, which is -2, and we're taking that to the 1/2 power. So we get 12 plus 4 to the 1/2 power, which is 16 to the 1/2 power, which equals 4. Okay, letter B. We have the limit of f of x times 5 g of x, and as x approaches c. So we're going to rewrite this as the limit as f of x as x approaches c times 5 times the limit as x approaches c of g of x. Substituting our values then, the limit of f of x is 3, and we're going to multiply it times the 5, and the limit of g is -2. So multiplying all those numbers, those 3 numbers together, we get -30 for the limit of our problem. Okay, next we have the limit as x approaches c of 7 minus g of x squared. So rewriting this, we're going to have in parentheses or brackets the limit as x approaches c of 7 minus the limit as x approaches c of g of x. And once we find those values, we're going to square it. The limit of a constant is, of course, that constant, so 7. The limit of g of x is -2, so this is going to become +2. And we're squaring that. So we're going to square 9. So our limit is 81. Next one's a little longer, but really not any harder. You just have to apply your limit properties. So rewriting this one, we get, letter D, we get 2 times the limit as x approaches c of f of x plus 3 times the limit as x approaches c of h of x. That's going to be divided by the limit as x approaches c of h of x minus the limit as x approaches c of g of x. Okay, substituting everything we know, we are going to get 2 times 3, our limit of f, plus 3 times 4, our limit of h, and that's going to be divided by our limit of h, which is 4, minus a negative 2, because our limit of g is negative 2, so that's going to be 4 plus 2. So we get 6 plus 12 over 6. We get 18 over 6. And so our final answer is 3. Okay. Again, I'm going to leave the last two for you guys to do. So take a second, pause the video, do them, and then I will write the answers. Okay, there's the answers to the last two. So E is 36 and F is 3 over 2. And again, I'm also going to leave example 3 to you to do. And you'll see it's a little more involved, but not any harder. And I'm not going to post the answers. So we'll talk about this one in class, example 3. So we'll see what you get for this problem. Okay, moving on then. Now we're going to do some limits of compositions of functions. So example 4 gives us our functions. We're given f of x is x to the third minus x squared plus 4x minus 1. And g of x is negative 2x. So we're supposed to find the limit as x approaches 2 of f of g of x. So we want to rewrite it using our limit property. So we want to think of this limit of, in this respect, f of the limit as x approaches 2 of g of x. Okay, so breaking that down anymore, what we're going to see is we can substitute in for g of x, what g of x is, and in this case it is negative 2x. And then we can treat that using our limit properties and think of that as a constant times our identity. And this would, rewriting this part, would give us negative 2 times the limit as x approaches 2 of x. And that's our identity. So that would just give us 2. So this limit now becomes f of negative 2, the constant, this constant, and then the limit of the identity, which would be 2. So what we have to find is f of negative 4. So now what we can do is substitute that into the function. So we're going to have negative 4 cubed minus negative 4 squared plus 4 times negative 4 minus 1. So we get negative 64 minus 16 minus 16 minus 1. And so the value of our limit is negative 97. Okay, letter B, very similar, except we've flipped the order of f and g, the same two functions I'm using. F is still x cubed minus x squared plus 4x minus 1, and g of x is still negative 2x. And I'm going to streamline this. I'm not going to write out breaking down the polynomial into separate limits. As I had mentioned, that's where the addition property comes into play. So you can think of each term as a separate function. So we have, just like I have written here, an x cubed, an x squared, an x, and also a constant. We can think of those each as a separate function. And so we'll end up for each of them a power rule, oops, helps if I press that, a power rule and the identity rule. So we're really just doing a direct substitution. So instead of doing that minutely, hopefully everyone understands where I'm going with this. If not, we can discuss it in class. Okay, so rewriting the limit here, we're going to write this as g of the limit as x approaches 2 of f of x. So finding the limit of f of x, we're going to take g of, and I'm going to substitute the 2 in the function of f of x to find the value of the limit. So I'm going to have 2 to the third minus 2 squared plus 4 times 2 minus 1. So I'm finding g of 8 minus 4 plus 8 minus 1. So I'm looking for g of 11. When you add this all together, you get 11. And g of 11, this is going to be substituting 11 in for g. And we get a value of negative 22. Okay, we can do the same thing using graphs. Again, I'm going to do A and B, and then you can do C and D on your own. Okay, so F and G are listed graphically, and the first limit they ask us to find is the limit as x approaches C of f of g of x. So we are going to rewrite this using our composition rule as f of the limit as x approaches 3 of g of x. Okay, so looking at our graph of g of x, we're looking for the limit as x approaches 3. And so here is f of 3, or I'm sorry, g of 3, which is also the limit, and the value is 1. So our limit becomes f of 1. And when we go to our f graph, we're going to go where x is 1. And so we are right here at negative 2. So the value of our limit is going to be negative 2. Okay, letter B. We want to rewrite this. We're now looking for the limit of g of f of x as x approaches negative 1. So we're going to find g of the limit as x approaches negative 1 of f of x. Okay, looking at our graph of f, we're now looking for the limit at negative 1. So going to negative 1, and we see that the limit is here at negative 6. So we're going to be looking for g of negative 6. So we go to our g graph, and we're going to go to negative 6. And at negative 6, we can see that it's off our graph. So we can use some things that we notice about this part of the graph of g. We have a linear function, and it's not going to be changing anymore because if it were, they would have to show us that part of the graph. So what we do see on the graph is that g of negative 4 is equal to negative 3. And the other thing we can notice on this graph is that going to the left, we have a slope of this line of negative 2. So that would make g of negative 5, and g of negative 6, negative 7. So that's what we're going to substitute in for our value of our limit. So g of negative 6 is going to equal negative 7, and that's the limit of our composition. Okay, again, take a moment, pause the video, try the last two, C and D. I'm going to post the answers in just a second that you can check, and then we can talk about these in class. Okay, so for the last two, I put a hint for the letter C. What you're going to notice when you look at the graph as x approaches 1, that we have a discontinuity. So you want to think about what the left hand and the right hand limits are doing. And then we can go over that one in class. So looking at the graph, because we're going to take the limit of g as x approaches 1, and what you can see is there's a break there. So you want to approach this as doing two different function values. So you're going to do a right-hand limit for g here and a left-hand limit for g here. And then you're going to use both of those to find f of x. So just think of it that way, and then we'll talk about it in class. Letter D, on the other hand, is much more straightforward. So good luck.